Alright, so we're first going to start by going over the development architecture and the environments used in this project. So the primary programming language in this project was JavaScript. We used a couple different versions. We did use Node.js for writing our API, and then most of the other JavaScript for the app itself was just vanilla JavaScript. We did use the Node package manager for a lot of the packages we needed for our server-side API. JavaScript object notation was also used a lot because it was storing our data and sending that over HTTP requests, and most of the things in the database are stored in such manner. So we basically used a mean stack approach for this project, so mean being MongoDB, Express, which you did use for routing, Angular, and then Node.js. The primary platform or framework that we used was Cordova. Cordova is made by Apache, which everyone knows that Apache makes servers. They make programs, I guess, or software for our servers. Predominantly, we used HTML, CSS, and JavaScript/JSON for it. The nice thing about Cordova is that it does let you cross-build your applications, and it saves you a lot of time because you can just write it in general for either app, and then it compiles down natively to each individual platform. So we ended up using the HTML DOM a lot for manipulating the layout and the styling of the application. One of the most useful things in here that we used in terms of packages was a barcode scanner plugin, which was provided by Cordova, and this gave our phone access to a barcode scanner that used your camera, and then it would capture a barcode and be able to accurately save the numbers so that we could use them for storing stuff into our database. For our CSS framework, we did use Onsen UI. Again, this framework is nice because it had iOS and Android built into it, so you wouldn't have to write two different versions. In terms of server tools, we did use Google Firebase. This is for our authentication. Then we did use AWS and MongoDB together. So the AWS, we used an Amazon EC2 instance. So this was a remote server. This hosted our Node.js API. It was a RESTful API. And then it also hosted our MongoDB instance, which was always running in the background. And basically that allowed us to send data to our server. And then that data would be stored into MongoDB in our database. So next, we'll go over some testing procedures. So first and foremost, we use Postman when writing our API. Postman is a really useful application, very popular. Most people know it and use it. It basically allows you to quickly send HTTP requests from this application to a given address or server. So in this case, it would be to our remote Amazon EC2 instance. So we could quickly test routes and make sure that we would get a 200 OK response from the server, just to make sure that our server was working properly. We also used a program called Mongo Chef, which was made by Studio 3T. And again, this is just a useful application because it provided us with a UI client for MongoDB. So this eliminated the need of having to remote into the terminal through a terminal using SSH to our Amazon server, and it would give you a visualized organization of the database and all the objects and collections that were contained within. And then we also use Google Chrome, their development tools and inspection tools, just so we could emulate devices quickly over the browser instead of having to deploy to one of our phones every single time we needed to test a specific feature or just to implement something new. Alright, so here we'll go over our MongoDB structure. So MongoDB uses NoSQL, which means it's a document-based storage. So all of that data is stored as a collection of JSON objects, which again are JavaScript object notation objects. So you can see here, this is basically what the what that structure looks like. Usually you have what's known as the key and then the value, which could be, different types. It could be ints, strings, doubles, so on and so forth. Here we had, this was kind of like the building block for when we had to save a list that contained multiple UPCs with quantities. So these objects are stored into the database, and every time they're stored, we have a new object being inserted. So one of the useful things we did was we created a user key and a creation date, so it would let you see who created this object and when exactly it was created using a date object. And the other cool thing about Mongo is that its shell scripting language is basically JavaScript. So anytime you had to do any sort of shell queries, or even when you had to do when you were writing the queries in Node.js, it was all JavaScript. All right, so AWS, or Amazon Web Services, were also a very integral part of our project. This allowed us to use their EC2 instances. It's basically a remote server that let us host our database and our REST API. Amazon Web Services are really cool technologies to learn and use, especially because they have a lot of free stuff for students. So if you do any sort of web development as a student, it's definitely a good idea to check them out and use their free tier packages that they have for use. So these servers use Amazon Linux 2, which is basically a derivation of Red Hat and CentOS. Within our Amazon server, we hosted our REST API, which was written in JavaScript or Node.js, and the server also hosted our Mongo database instance. So that instance was always running and watching for calls that would be made from the API. And then lastly, here we used Git and Git Kraken for our, development environment. Obviously, Git is a very important part of any development team and any development workflow, because you need to be able to control your versions, revert back to any previous versions in case there's any issues or errors. The cool thing about this particular program, Git Kraken, that we use is that you basically just use your GitHub account, and it'll list all your different repositories. It gives you a nice UI that lets you visualize and see all of your branches and different commits that you've done in a cool timeline. It's very useful, especially when you have multiple people working together, because then everybody can track the progress, and then whenever you need to do any sort of merge commits, then it has an in-program merge conflict tool, which allows you to see the different merge conflicts that will arise when you try and merge different branches together. It's like which snippets of code that you're going to be using. So again, very useful for when you have 3 or 4 different people working on one project or one particular section. And the way that we chose to do it is we had 4 branches, each one for each individual developer. Then we had a development branch, which was where we all merged into, and that was basically our testing branch. And after that, after everything was good to go and everything on the development branch worked properly, then we would merge that into our master branch, and master branch was basically the finalized copy of the project or the repository. So essentially everything in master is the current version, if you will, of what you're getting inside the application.
Hey guys, it's Jude again. Here we're gonna talk about the file path and the system modules, like how we divided our work in this project. So basically, once you start up the app, you start over here in login.html, and you've got to log in to get to the rest of the app. We use Firebase to authenticate to authenticate the process of the login. So once Firebase has like a valid authentication or a successful login, it will allow you to move through here and into the index.html. The index.html in our case would be like the landing homepage, where you can see all the list of the users. That's primarily going to be in in the home page right here, and you're gonna be able to see basically all the lists. And if you click on them, there's another page here inside homepage.html that will show you the details of a list. If you want to go ahead and add a new list or add or scan new items, then you'd be able to go here into the add inventory HTML, and that's where we have the process of basically scanning items, creating the new list, and then saving the list and shipping them off to the MongoDB, where they will now show up in the home page once you want to see all the lists, pretty much, because that's the home page represents all the lists that are in the MongoDB at the moment. So over here, if you want to deal with any of the user settings, if you go down here, user page, you'll be able to see the information about the user. You'll also have the access to, not access, but there's a button there that lets you edit the user page. So, not really edit, but there's a button here that changes you to the user list page where you can see every user, and that's obtaining the data from the MongoDB. So from the edit user list page, you're also able to click a button that will let you edit the user. And once you edit the user, it goes to the MongoDB and it'll update the user, and you'll see that change reflected in the user list page. So about the modules we have when it comes to this project, there's really two modules that we separated our project into to focus on building this. There's the user side and there's the inventory side. So the user side is pretty much logging in and working with these three files right here, where the user is able to check other users, check their profile, edit other user information, update user information, stuff like that. They're also able to pretty much just retrieve information about a user's list from the MongoDB, especially if they're an administrator. So the other side of the project is the inventory side, which would be these three things right here. So once you log in and you get to the home page HTML, you're going to see a list of all the inventories. You're able to click into them, and this is all dealing with the functionality of dealing with the inventory system. So of course the user is involved in both of these aspects, but this side of the program or app is more focused on managing the inventory. That's its job. So within here, like I said, you'll be able to see the list, you'll be able to click on them, you'll be able to edit them or update them in the homepage.html page, which is also part of another page that's in there. So over here we have the add inventory. That's allowing you to once again add things to the MongoDB and update or make new lists pretty much. So basically these things here, they comprise the inventory side of the application, and these things here, they comprise the user part of the application, and together as a whole they form the main application together, as those are the two sides of the coin, if you want to say that, and together they complete the whole product. Thank you.
Hi, I'm Mihail Gaboris from Team Jefferson, and this is our demonstration of InvenZip. So we're first greeted by the login screen. We'll put in our email address, just like that, and then we'll put our super secure account information in. And now we've reached the home page. So we're greeted with a list of items here. We can look at Best Buy, for instance. Best Buy has these items. We can edit the name of the list, so we can call it something like Target in Tampa. Go ahead and update that and press update. We can change the quantity of the items. Maybe we want, I don't know, 7. We can then go ahead and scan items on this home page as well. So this is our scanning page. So we can scan something like a chocolate bar. So give it a second. Scan. You can say we have 17 of these. You can go ahead and scan Icebreakers mints. Have 30 of these. And we can go ahead and scan some dish soap, because why not? Oh, this one's giving us a little trouble. Oh, but we got it. 3. Cool. We added those. We can call our store. I don't know. What should we call our store? Haven't decided yet. But I think we can call our store. Oh, never did that. Better fill out. Item location. We can call our store Publix. And we can say we're at USF. And now we can press add, or not add, I'm sorry, save. And we've just successfully saved our items. And if we go back to the home page and we scroll to the bottom, we can see Publix, and we see our items are here with their respective quantities. This is our user page as well on the right side. So as you can tell, I'm logged in right now. My title is a warehouse manager, and there's my email address, and we can see all the current users. We can also go ahead, and if I wanted to, I could change a user, but I'm good for now because that's who I am. So we'll keep that, and we can go back, we can log out, and that's our app. That's InvenZip.